This video is going to cover determinacy for trusses. Our equation is just a little bit different than it was before when it was for beams and frames. This time we have an extra variable in there, and it's not 3 times, it's a 2. So B is the number of bars. So the number of members now in our truss. R is, it's still reactions, but it's very specifically the number of external reactions. So no longer do we care about those hinges because we pretty much have a bajillion hinges in a truss. We only care about the external reactions, so those pins and rollers and fixed ends. In J, on the other side, the 2 times J, J is the number of joints. So now it's effectively the number of those hinges that you have all through the member. So again, it's the same thing, whether it's greater than, equal to, or less than. Again, still the same. We want equals. Equals is obviously determinant. And then again, we just want to look at this in terms of where R is, R being the number of reactions. If we have too many reactions, we are then going to be indeterminate. And if we don't have enough reactions, we're going to be unstable. So let's go take a look-see. Here we have a wonderful truss. We got 3 effectively big triangle pieces. So let's just start counting. We've got number of bars. So we have 1 bar here. We have a bar here. Vertical bar, another bar. This bar down here at the bottom, another one over here, and this one also at the bottom. So we have 7 bars. So 7 bars, plus we need the number of external reactions. So at a pin, we have a vertical and a horizontal, so that's 1 and 2. And at a roller, we have 1, so we have 7 plus 3. And we want to know how this compares to the number of joints. So this is a joint, right? At the pin, that's a joint. This is a joint. This is a joint. This is a joint. Again, at the support, that's a joint. So we're looking for 2 times the number of joints. There were 5 joints. So 7 plus 3 is equal to 10, and 2 times 5 is also equal to 10. So this is equals. So this is a determinant truss. Wonderful. Let's look at another one. Here we have one where I did a little bit of magic right here. I'm just saying that this member goes behind the vertical member. They don't meet up per se and have a joint. The only joints are going to be at the supports and at the corners here. Those are the joints that we have. So let's count it up. Number of bars, we have 1, 2, the vertical is 3, 4, 5, the horizontal is 6. So we have 6 bars. How many external reactions do we have? We have a vertical for the roller. We have a vertical and a horizontal for the pin. So 6 plus we've got 3 reactions. That's for 9 right now. And then we're looking for 2 times the number of joints. So we've got 1 at the roller, 2 at the pin, 3 at the top, 4 at the side. So that's only 4. So 9 compares to 8 as being too many. So this is indeterminate. This is an indeterminate truss. Would have been a little bit better had we had a joint there in the middle, but because that member kind of went around the other member and didn't meet up, it's now an indeterminate truss. And lastly, this is like the same truss, but we added in 1 extra member. Let's see how that affects things. So the number of bars, we got 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 members here. And then we've got How many reactions? 1, 2, 3. And how many joints do we have? 1, 2, 3, 4, 5, 6. So again, this is going to create, we have 9, plus we've got 3, and we want to know that's 12, and how does that equal up to 2 times 6? Wow, it's still equals. So even throwing in one other member here, we're going to make another triangle in this little area. So we included one member, that gave us one joint, which actually gave us a second member if you want to think about it this way. So we had 2 for the joint, and we actually created 2 other members, which is why this still worked out. So it is kind of good to note that creating indeterminate trusses, unstable trusses, if it's pretty much stable already and determinate, then you've really got to work pretty decently, not by just joining up more things. You kind of have to do the bypass method in order to get things to be a little bit indeterminate. Otherwise, you can just, change it to having, say another pin instead of a roller, then it could be indeterminate. Or if you put a roller instead of a pin, it could be totally unstable. So that is just something to note with trusses.